Started from the bottom, now we here. I was gonna give up, cause my future wasn't clear. But we started from the bottom, now we here. Started from the bottom, now the whole team here, man.
All right, here we go. Let's get this next chapter started here. Mr. Brust, I'm bringing you the next chapter here on rational expressions. Pretty fired up about this chapter. This is a pretty great chapter here. To get things rolling here with rational expressions, we're going to talk a lot about simplifying them and are they equivalent. And if you can check it out, obviously I'm going to give a shout out to one of my favorite artists. There's Drake right there. Pretty much I think him and I are equivalents. That is a picture of me on the right. I think we're equal. Why? He's got a pretty fresh cut. I got a fresh cut. He's got a pretty tight beard. I got a tight beard. What else? When Drake thinks about rational expressions, there's a little rational expression he thinks about it. I think about one too. It may look a little bit different, like we're not exactly the same. You know, mine is a little cooler. My beard's a little cooler than his. But these are the same things. His rational expression is the same as my rational expression. They're just one simplified. So we're going to find out how to make them equivalent and which ones are equivalent rational expressions. Here we go. Let's do it. So first of all, we're going to bring it back to numbers. Before we get into expressions, let's talk about rational numbers. What are rational numbers? Well, you've done them forever. Maybe you didn't realize what they were called, but it's anything that can be expressed as a fraction, and that's a lot of things. Basically, 2/3 is a fraction, so it can be expressed as a fraction. How about just a plain old number like 5? Sure, 5 is a rational number. Why? Well, you can make it 5 over 1. You can make anything a number over 1. What are some things you can't do? So pretty much any number you can think of. Negative 32, rational number. All these things are rational, even decimals, you know, like 0.75, you're like, well, how do you make that a fraction? Well, it's 3/4. So these are all examples of rational numbers. Are there things that are irrational? Sure. So irrational would be things like pi. I can't make these repeating decimals, these non-terminating, non-repeating 1.14, blah, 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 I don't know what it is. That can never be a fraction, so this is not rational. Some square roots will do that too and things like that. But basically, the numbers you're dealing with are fractions. So how do we know if they're equivalent? Well, let's take a look at this one. Are these equivalent numbers? Sure. 2/3 is the same thing as 4/6. Why? You just reduced it. If you reduce this, you get 2/3. So this is stuff you've been doing forever. Same thing. You can take 12 over 18 and you can reduce it. It is still 2/3. You can even go as far as to say 50 over 75. They all reduce down to 25 goes in there twice, 25 goes in there 3 times. 6 goes in there twice, 6 goes in there 3 times. So they all reduce to 2/3. They're all equivalent. They're all the same fraction. You're good to go. So great. How does that relate to a rational expression? Well, just like numbers, we're going to do it with what we're going to have expressions. And what are these expressions? They're just a ratio of 2 polynomials. So don't freak out. Ratio just means fraction. It just means division. Just like a fraction means division. And we're going to do it with 2 polynomials. So all last chapter we're looking at polynomials. So we're going to look at some polynomial p divided by some polynomial q. The key to this is q is not allowed to equal 0. And we're going to talk a lot about that. Why? So these are polynomials. So I'm going to take 2 polynomials, put them on top of each other. So here's an example of one. You could say 2x plus 1 over 4x minus 7. That's just an example of a rational expression. It's 2 different polynomials stacked. They can get crazy, or they can be pretty simple like this one down here. So let's start with these. Are these equivalent rational expressions? Well, I hope so, or I give you a pretty bad example to start with. But yeah, doesn't this reduce? You can just reduce this to 2/3, so 2 over 3x. So that's cool. How about this? A little bit trickier here. Is that the same thing? Yeah, man. Sure, you can cancel these x's. This is division. So I'm going to divide this x with this x, and what do I get? 2x over 3. So that's cool. Making this a little bit more over here. What about this? It's all times up here. So as long as you're multiplying, we can divide these out. Since multiplication, when I divide these out, what happens? This cancels this, and look what I'm left with. 2x plus 3. So you can see these things get a little bit crazier and crazier, huh? How about this one right here? Ooh, it doesn't look very equivalent to me, does it? Well, we can kind of make it so it does. If you factor what's going on here, like on top they have a 2x in common, I can undistribute that or factor that greatest common factor out. Take out 2x, what's left? You've got x minus 3. Boom. What about on bottom? What do they have in common? A 3. Take that out, and you've got x minus 3. Oh, looky here. What's going to happen here? X minus 3 cancels x minus 3, and what are you left with? 2x over 3. Boom. They're equivalent. They're all equivalent. How about this monster? Whoa. He doesn't want to come. He doesn't even want to come out. Here he is. Look how huge this thing is here. Is it going to give me 2x over 3? Is it going to be the same equivalent expression? Well, I hope so. The top's already factored. That's cool, but this bottom's a mess. Can I factor the bottom? Well, sure. Look, if you look at it, what do they all have in common? A 3, so you can take a 3 out, and you're left with what? X squared plus 7x plus 12 right there. And then that factors again, doesn't it? What multiplies to 12 and adds to 7, so you can say break this bad boy down again. You've got x plus 3, and you've got x plus 4. And because it's all multiplication, I can start dividing right now. I can say x plus 3 divides x plus 3. X plus 4 divides x plus 4. Look what's left. 2x over 3. So this crazy thing over here on the far right, whoa, this whole thing equaled this whole thing over here. These are equivalent. Man, if somebody walked in right now and saw your screen, they're like, Mr. Brust is crazy handwriting. That is ridiculous. But the last one is the same as the first one. They're all equivalent. They're all the same. We just wrote them a different way. So that's what we're going to do. Now, if you notice I said something about like, hey, the bottom can't equal 0. Why is that? We're going to talk about these excluded values. So you may need to pause and write that down. They're values that make the denominator equal 0, or they make the bottom, you can't divide by 0. So anytime I'm when I'm dealing with these things, and I want to find some excluded values, sometimes it's called the restricted values. It's just the problem values, really. You can't have the bottom equal 0. And it kind of reminds me of Drake. Started at the bottom, now I'm here. Same kind of thing. When I look at before I start, I'm going to start at the bottom, and I'm going to say, hey, man, the bottom can't equal 0. I'm not allowed to legally divide by 0. It's just impossible to divide something into 0 parts. So you can't have a candy bar and say, I'm going to divide this into 0 parts. Like, you can divide it into 2 parts. Like, I got 2 friends, I'm going to cut my candy bar in half. Or I got 3 friends, I'm going to cut it into thirds. Or I've got 1 friend, I'm going to give them the whole thing. You can't have no friends, but you can't divide it into no friends and no parts. It just doesn't exist. So what happens? I set this as it can't equal 0, so I don't even care about the top. Who cares? You can even cross it off for this example. Don't even care. I'm just focusing it on the bottom. So just solve this equation. What am I going to do? I'm going to subtract 7 from both sides, and I'm going to say it's negative 3x cannot equal negative 7, and then what am I going to do? Divide both sides by negative 3. So in this case, my excluded value is x is not allowed to equal negative 7/3. It just can't equal that number. It can be any other number I want, but I can't do 7/3, or that would make the bottom equal 0. That's a big no-no. How about the next one? Again, start at the bottom. Now I'm here. Start at the bottom.
Started from the bottom, now we're here.
So I can't equal 0. What do I got to do? Just add 5 to both sides. So I'm going to say u can't equal 0. N squared is not allowed to equal 5. Can I solve this equation? Sure. If n squared equals that, I'm going to square root both sides. Just be careful what happens when you introduce a square root. Boom, every time, plus or minus. That looks terrible. Let's try it again. It cannot equal plus or minus the square root of 5. So there's 2 answers in this case. Cannot be the square root of 5, because if I put that in there, I'll get 0. Ooh, look at number 3. It gets a little tricky here. Kind of mix it up. Again, I don't care about the top. I'm going to start at the bottom.
Started from the bottom, now we're here.
So, boom, I got this. It can't equal 0. What do I got to do to both sides? It doesn't matter who you solve for. I don't care. You can do it either way. Let's just solve for the x. So I'm going to move one of the variables over. Doesn't matter which one. Then you get 2x can't equal negative y. And if I want to get x by itself, what do I got to do? I got to divide by 2. And so x cannot equal negative y over 2. So that is my excluded value. So in this case, it's kind of weird. When you solve for it, you actually get a variable in your answer. If you would have solved for the y, no worries. You could have solved for the y. You could have said 2x plus y can't equal 0 and said, hey, actually it would have been easier, wouldn't it? Just to solve for the y, what do you got to do? Just subtract 2x from both sides. If I subtract 2x, I get y can't equal negative 2x. So these are the same thing. Either one of these is cool. However you want to write it, it's the same difference. So pick a variable and solve for it. Awesome. So we're cruising. This is great, man. I can find these all day long. Don't care about the top. Go to the bottom. Bottom can't equal 0. Find that excluded value. I'm just going to solve this bad boy real quick. So what do? Wait a minute. Minus 4 minus 4. I get y squared can't equal negative 4. Hey, wait a minute. What number can I square and get negative 4? Well, even if you didn't catch that. Let's go ahead and pretend I didn't catch that. I'm going to square root both sides to solve this. Can I square root a negative? Is there any answer here? No, this is not impossible. I can't do this. This is a non-real, this is an imaginary solution. This is not till later on in the year. So I can't do this. So this has no solution. So sometimes the bottom will never equal 0. This is a case. This is a non-real solution. So this has no excluded values. So there are no restrictions here. There are no excluded values. The bottom's always positive is what that means. This number, well, it's not always, okay, it's just not 0 ever. How about that? And this y squared is always positive. That's why that plus 4 won't ever come back to 0. So sometimes you don't have excluded values. So don't freak out. That can happen. Excellent. So now we know about the restrictions. Why do we have those restrictions? Well, I'm going to ask you something like this. Hey, is this rational expression over here equivalent to this rational expression over here? And here are the restricted values there. So if I want to show, are they equivalent? Well, I got to do some of my factoring. So let's factor the top. What comes out of the top? They have a 3 in common. So I've got x squared minus 4. Does anything factor on the bottom? I hope so. So I got what multiplies to 8. It looks like 8 minus 4. 8 plus 2. Is that right? Yeah, that looks good. And does the top factor again? I think it does, doesn't it? Ooh, I should give myself more room. Let me kind of move this guy out of here, the way here. And the top factors again. This is a difference of squares, so really that breaks down to x plus 2, x minus 2. And now does anything cancel? Sure, my x plus 2 is going to be divided by x plus 2. And is that equivalent? Well, I've got, they look pretty good, don't they? The bottom matches. What happened on the top? We just got to redistribute. So if I redistribute the top, I'm going to get 3x minus 6 all over x minus 4. Yes, these are equivalent. I'll put a big smiley face. That is a terrible smiley face. That is rough. But they are equivalent. So you can prove they are exactly the same thing. Fantastic. We are killing it. We only got a couple more. I think we got 4 more of these, and we are done and done. Best video ever. So I'm going to ask you to reduce these things to lowest terms and state any excluded values. If there is one. So first, when I do this, I'm going to find the excluded value. So what I do is I take the bottom, and somewhere off down here, I say, I'm going to find the excluded value, just so I don't forget. So I'm going to say, hey, I'm going to start at the bottom. Now I'm here. Boom. And does this bottom factor? Sure. What multiplies the 48 and gives me 2? Should be plus 8. Be careful with those signs. And what? Minus 6? 6 times 8 is 48. So that can't be 0, so I'm going to get 2 solutions here. What is this? A is not allowed to be negative 8, and A is not allowed to be positive 6. So I know you guys are good at factoring, man. I know because I've seen you go through Mr. Sullivan and Mr. Kelly's stuff, and they had a ton of factoring. So you're good at it. So these are my excluded values. So I can't have A be this or it messes everything up. But what's cool about that, since I already factored it, that's great. Now I know the factors here are A plus 8 and A minus 6. And on top, let's factor this. What do they have in common? Looks like I'm pulling the greatest common factor of 2a. And what's left? If I take 2a out of 2a squared, I'm left with a. And then what's left out of this? You've got 8. And does anybody cancel? This only works because it's all multiplication here. A plus 8 cancels a plus 8. And what am I left with? I'm left with 2a on top. And I'm left with a minus 6 on bottom. My a's are rough. Woo! There we go. That's a little bit better. So this is reduced to simplest form or lowest terms. And there's my excluded value down there. Awesome. Very nice. So again, let's do the next one real quick together here. So again, I just take the bottom if I want looking for the excluded values. And I like this example. This one's super cool. Why? Because it's already factored for me. So I can do these all day long, man. Somebody took the time to factor this. They just didn't go ahead and find the excluded values and solve. So what are my 3 solutions here? Remember, you get 3 of these. So when does 3r equal 0? Well, 3r can't be 0 because that would make this 0. R is not allowed to be 2. You may have to do a little work here. Remember, you're really saying 2r plus 1 can't equal 0. So you got to subtract your 1 from both sides, blah, blah, blah. 2r equals negative 1. Divide it. You get r can't equal negative 1/2. So you do have 3 excluded values here. So you've got 0, 2, and negative 1/2. Cannot be there. It's going to be hugely important coming up later in this unit for looking for these excluded or restricted values. Now when it's done, can I just cancel? Because it's all multiplication, I can say, yeah, if I divide these two, this is gone. 4 and 3 don't reduce. Nothing else really going on. So you can leave it like this. I'm totally cool with you leaving it factored. If you want to multiply it back out, nothing wrong with that. It's the same thing. It's an equivalent one. But that's totally cool if you want to leave it in factored form. Either way is good. I'm kind of lazy. I'm going to leave it in factored form. The final 2, and I'm sure I picked these for a good reason. So why did I pick these? Well, I think I kind of wanted to up the ante in the factoring department here. So let's do the bottom. Start at the bottom. Start at the bottom. Not the whole team's here. There it is. So I'm going to write this out as, so I can't equal 0. Not allowed to equal 0. So what do they all have in common? They all have an m, so you got to always start with pulling out the greatest common factor. It's the biggest thing that divides this. Well, there's an m, so you're left with m cubed divided by m is m squared. 6m squared divided by that is m, and 27 divided by that is 27, and that equals 0. Awesome. That's a rough-looking 0 right there. So we got this. Now, can I factor that again? Sure. I'm going to say, hey, what multiplies to 27 and gives me 6? What is that? 9 and 3 maybe? So I got m minus 9, m plus 3, and that equals m, and that can't equal 0. Awesome. So now, what are the solutions? M is not allowed to be, you got this m out here, so m can't be 0. M can't be 9. That would give me a problem there, and m can't equal negative 3. Awesome. So here are all my excluded values. Whoopsh, got that. Now I can go back up, and since it's already factored, I'll just write it underneath here. Once you have it factored, I've got this, and there we go. And so now all I got to do is factor the top. So if I factor the top, what happens here? They also have an m in common. That's cool. So if I take the m out of m cubed, I get m squared. And then I've got this 9. Whoa, that's pretty cool. Wait a minute. Factors again. M squared minus 9 is a difference of squares. Remember, that turns into m plus 3. Aren't you guys glad you factored so much? You guys are professional factorers like this. Now, I double factor. Does anybody cancel? Yeah. This is going to be divided by this. This is gone. I've got m over m. Ooh, I should have done m and m instead of Drake. That would have been good for this one. Those cancel. So what's on top? M minus 3. What's on bottom? M minus 9. So I've got, this is my reduced simplest one, and you're good to go. Okay, let's take a look at the last problem here. Final one here. I love it. The bottom of this one's easy peasy. You say 3h can't equal 0. So what does that mean? H can't equal 0. So we do have an excluded value. H is not allowed to be 0. Does anything factor? So this is where people sometimes get cancel crazy. They're like, oh man, I'm just going to cancel this H and maybe this 3 and this 12. Don't do that. That is totally wrong because this addition sign messes it all up. So you can only cancel when it's multiplication. So don't go cancel crazy on this thing. We really got to think about we're dividing. And what are we dividing? Well, if I can factor something in here, I'm cool. So does anything factor on top? Yeah, you can take an h out on top. And you're left with 12h plus 5. So all I could pull out on top was an h. But now that it's out here, I can say, yes, this h cancels this. That's awesome. I'm good to go. So really, I have 12h plus 5. And then on bottom, I have 3. So don't go cancel crazy. Don't try to tell me that's 4h here. It's not. It's the whole thing. It only works around multiplication. So that the whole reason I have this example is this division, and you're dividing it out only when it's around multiplication. That is it, man. So hopefully that went well for you. Do the practice. See how it goes. Grade it. Good luck on the match check. Peace.